later on for people who couldn't make it, so be able to see it. So I believe the recording's on. Could you, let's double check that really quick. Yeah, I think it has the, yep. All right, the recording is on, and we'll go ahead and get started. So, this webinar, like we said, it's going to be the path to data engineering. So we're going to take just one quick minute as sort of the agenda to tell you guys about what is data engineering. Because to be honest, actually, we still get that questions a lot. So just one slide we have, we're going to go over what is data engineering, and then we quickly dive into what you have to learn, how to be a data engineer and all of that. We also have like a brief short demo for you guys on some of the sources that we think are really good to learn data engineering that might not be as visible to a lot of people, you know, when you Google search out there. So we'll show you some of our favorite tools out there, and then we'll talk about our program towards the end. It's me, Parham. I'm one of the data stack guys, and my colleague here, Guy. So we'll take you through this. Go ahead, Guy.
So one question that a lot of people have, and this slide has some details, is what's the difference between data engineering and data science? Data science has gotten a tremendous amount of attention in the last few years, and data engineering is a label that's newer that not a lot of people are familiar with. So this pyramid here gives you a good idea. You can see on the bottom or on the top two segments of the pyramid are the data, the bottom four of the pyramid of data engineers. So you can see this is collecting data, moving, transforming, aggregating, and the top two are on the data scientist side. So you've probably heard the terms back end and front end. Data engineers are on the back end and data scientists are on the front end, meaning that they build the models and present those models to decision makers. So one thing that a big part of the growth of data engineering in the last few years is that data science has gotten a lot of attention, but a lot of organizations are realizing as they try to bring in data science that a tremendous data infrastructure is required for that. And that's a big part of our job as data engineers, is to build that infrastructure that allows the data scientists and the analysts and the people on the front end to do their jobs. So this chart is a good visual way just to see a little bit how that divides up.
Thanks a lot, guys. So I'd like to spend just a quick minute. Like we've all heard a lot about like data's future and data science, data engineering. These jobs are very prevalent jobs out in tech now. I'd like to give you guys some numbers maybe that you haven't seen. And again, these are from very accredited resources. And data engineering is the fastest growing job market in tech right now. And when we send you guys these slides, so I'll have all the sources actually linked behind these numbers, but these are some of the numbers that we've seen. Again, don't take this from us. These are some very accredited sources that are saying this. So the top number is from Bushworks report. They interviewed from summer of 2020 to summer of 2021. They interviewed 320 companies, 320 leaders in the industry. And out of that 320, 81% said that they hired data engineers that year. And remember, this was 2020 to 2021, so the height of the pandemic. I think that is great. That also shows the average salary for data engineers. That number's from Indeed. Right now, data engineering has the highest average salary in tech with 119. That's higher than data science, higher than full stack developers, higher than web developers, higher than app developers. And there's 40,000 jobs available in the US market right now in data engineering. Again, it shows that demand, and that's on Indeed. You can go on Indeed.com. There's data engineering page. You can take a look at those numbers. I think the biggest number that I'm going to show you guys here is that third number. That third number is from Dice report. That's Dice report again from 2020, pandemic year. And in that report, they analyzed 6 million jobs in tech, and data engineering was the fastest growing in tech. And on slide 15, if you go see that report, slide 15 of that report shows that number. And data engineering almost doubled the next one on the list, actually, with 50% growth. The other thing to notice there is um, some of the interesting other stats. So they listed, of course, Python, SQL, which we talked about as top data engineering skills. But right after those skills were a lot of skills around the cloud. There were Docker, Kubernetes, Azure. It was listed on that for data engineers to know. So it also shows the shift of this market shift towards the cloud. But it also shows that this job is really being done everywhere, because the other thing they listed was some of the fastest growing cities in US around tech, around data engineering. And like Columbus, Ohio, a lot of these cities from Midwest were on it, which really shows that like the traditional like New York, San Francisco, those big tech hubs, they're kind of going away, and the jobs are becoming remote, and people from all over the US are getting into these markets now. The last one, which is unlimited time off, I really don't know what it means, but it is listed as one of the benefits of data engineering on Indeed. That's again from Indeed. So if you go on that data engineering page on Indeed, it says unlimited time off. Again, that's sounds like a great benefit, yeah. But I don't know. Again, I don't know what it means. I kind of do. I mean, it is correct. Data engineers are so high in demand these days that you kind of manage your own time, and things are done remotely. So as long as you get your work done, right? Nobody really cares how or when.
And one thing I would add on data engineering jobs is that if you just go look at Indeed or any site, there's a lot of jobs posted for data science and data engineers. But if you look at the details on that, a lot of data science jobs might have hundreds of applicants. There's a lot of people heard about data science as a career and these eye-popping starting salaries and got into it over the last few years. But if you look at most of the data engineering postings, not only are there more postings, but there's a lot fewer people applying for those jobs, because there's just not as many people that have developed the honestly really big tool stack to do that. And that's why we're passionate about educating people on that, is because it's a really good time with a lot of opportunities out there for data engineers.
Yeah, that's a great point. And that shows in the salary. That shows it. I mean, it's supply and demand.
Yeah,
so
supply and demand, exactly. Straight economics.
Yeah. So I'll go ahead and get right into it. So how do you become a data engineer? And we have a very opinionated path here, but we think this is a good path. I mean, between you and I, we have a lot of years of experience, and my entire career has been in this field. But from really holistic point of view, I think there's two paths here to become a data engineer, right? There's a self-learning path, and there's another path that I'll show you in a second. The self-learning path, I really, really highly recommend this for people who are in tech already, some sort of tech, and they're trying to make that shift to data engineering. No matter which one of these two paths that you're going to choose, the very first place that I would recommend you to start is pursuing one of the cloud certifications. So all the major cloud vendors out there now, Google, Azure, AWS, they have some sort of data engineering or data architect certification. If you go on those websites, Google them, just go, find their website. On their website, they actually list a learning path for that certification. There's a lot of good free material out there. Follow those. There's really good. Start from there, follow the learning path that they give you. That's a great way to get started. I would highly, highly recommend that as you're doing this, no matter, again, which path you're going to take, build your GitHub portfolio. So when you're doing projects, when you're following these different learning paths, even if it's YouTube or other places, you're doing projects, do them in your GitHub profile. Make a GitHub account, make GitHub projects, commit. A lot of companies these days, including our company, we also run like a data engineering consulting company. We highly use GitHub to vet resources. And a lot of companies are doing that, again, because code doesn't lie, right? So when you go on GitHub, you can see somebody's skills very quickly. And even GitHub itself, they started realizing that, and there's now selling that analytics to companies. So they started realizing, oh, there's a lot of information here. We can tell who are the actual real good developers, and we can actually kind of sell that analytics to companies. So do it on GitHub. Do it with real-time projects and real-time data. It is hard to get your hands on real-time projects and real-time data, but there are really good sites out there like Kaggle, like DataHub.io. Kaggle is a great data science, data engineering website, which we'll demo you guys in a second. They have a lot of good data. They have good challenge projects. Get into those. Just start doing them. Grab the data. Again, as you build those, put them on your GitHub portfolio. There's a lot of good free resources out there. Of course, there's YouTube if you're more into learning towards, video and instructor. Of course, if you Google, you'll find tons of free resources out there. Some of the other ones that are not as prevalent out there are like Twitch. Twitch is a great platform to learn with others. We highly recommend that in a environment where you're learning with others. So you can use Twitch to create a channel and learn live. So if you let's say you can go on there and say, hey, on Wednesday night, I'm gonna tackle this Kaggle project. I downloaded this Kaggle project, I've downloaded data. If anybody's interested, we can get together and do this together and code this together and trying to figure this out. Great platform for that. Of course, there are a ton of paid sort of these online self-learning sources like Udemy, Coursera, DataCamp. They're great resources. They're low budget resources. So they kind of range between like $200 to $1,500, $2,000 for the courses that they have. These are great programs, but overall, again, this self-learning path, I really recommend it for people who have already a career or they're somewhat in tech, so they have a foot in the door. I think it's a lot easier for you if you have a foot in the door to follow one of these and kind of level up your education, level up a certification, and then go to the job market and be able to apply for that job. But if you don't have a foot in the door, if you're very new to tech, I would highly recommend this second path, which is boot camps. So boot camps, you've probably heard of them. There's these coding boot camps. They're very condensed, focused programs. You go in there for 3 months and you study one thing. So in this case would be data engineering, and you come out, you have the certifications, you have the qualifications, and you can apply for the jobs. The thing that I recommend for these, I think, is a few some of the benefits that these have that are hard to replicate in self-learning is kind of threefold. One I would say is the declared intention. It's the main reason that these programs have better results, because you really have to declare that intention when you go through these, right? You're like, all right, data engineering is my path. I know I can get a job at the end of this. It has a very good salary. It's stable. I'm going to dedicate myself for 3 to 4 months, and I'm going to go there every day and learn, and I'm going to come out being a data engineer. There's just something magical that happens in life when we declare intention, right? And I'm not here to say that self-learning doesn't have that. There's a lot of people that go through self-learning that can dedicate themselves, sit there every night, go through the lessons and do them and get results. But I would say even those people have declared intention, right? So no matter, again, what you choose, declare that intention. Great things in life happens when you do that. The other thing that is harder to replicate in self-learning environments is learning with others, right? Yeah. So in these boot camps, you are around a lot of other, 20, 30 different people that are same level as you, and they're learning with you. And you often have to interact with them every day. You learn together. You even put in places where you have to pair program together.
And that experience, part of what's valuable about it is it really replicates the kind of working environment that as a data engineer that you'll face every day with working with others in a collaborative setting. And that is really hard to produce on your own. So that's one of the big benefits of the bootcamp kind of style, for sure.
And again, and not to say you can't do that in self-learning either. Again, if you want to do that, platforms like Twitch, Discord, all these newer, kind of co-learning platform. We actually will show you another one in a second that are out there that help you for that. The last one, I would say, it's just in the self-learning environment, it's not replicable, and it's the career services that boot camps provide. And it's because the self-learning platforms, these sites, Udemy, Coursera, DataCamp, it's just not in their business model. The business model there is to have to sell a little to a lot of people. So the profit margins, per person are low, and they just cannot afford to pay that much attention to one person to make sure, that person has all the tools they need to enter the job market, to spend time with them, to groom their resume, to mentor them, to get them ready to be out there. They do hire like sort of mid-level these data engineer managers at companies, big companies like data companies like Facebook, Netflix, so forth, and mentorship, but you have very limited time to them. They don't really have that much time to spend with you. So in a boot camps, again, because the business model is different, the business model is around getting you a job. There's a lot more attention there. They help you actually get that career, the career services that you need. Again, this is more for people who don't have that foot in the door. Like, I think we highly recommend this. Of course, they have higher monetary and time costs, but they have better results at the end, typically.
So we'd like to talk a little bit now about this idea of what does the data stack actually look like? What is not only the division between data engineers and data scientists, but a really good example that I think everybody can relate to with this is rideshare. Almost all of us have probably taken a rideshare at some point. And if you think about what's happening behind the scenes when you're doing that, there's a tremendous amount of data. There's data about riders, about drivers, there's geographical data, there's transactional data, there's all of this data coming in to multiple sources in real time at high speed. And so part of the role of the data engineer is that somewhere further down what we call the pipeline, the data scientist wants to be able to get some insights out of that data and present it to somebody that needs to make decisions. But a lot's involved with that to be able to get to that point. So as data engineers, we do a lot of ingesting data, manipulating data. The term is ETL, extract, transform, and load. So there's a lot of taking the initial raw data and extracting different other features from it, other statistics, to get it into a form that's closer to what the data scientists and the end users need. And so the data engineers in the scheme of things are the people who, as a data engineer, you're most responsible, the person in an organization that's most responsible for the data. And that means that you're going to interface with just about everybody at some point: the developers, the data scientists, the IT managers, the people that are doing more of the administration, even now that cloud has taken over, that's still a big part of things. And so data engineers, their role isn't as obvious, but it touches a pretty much every other role in the organization. And that's why it's so important. So this also gets into the idea of what we call the dark sides of data engineering, because we want to be honest with people that this career is not for everybody. There's a lot of upsides and a lot of rewards. But so one of the things that is potentially a drawback is that it's, as CJ said, it's you're a behind the scenes hero, a silent hero. Everybody's heard of data science. There's been a lot of press in the last few years about data scientists, and that's been a very visible role. And it's not to say that data engineers are more or less important, but that role is also extremely important. But it's just one that you don't hear a lot about. And I think most people can relate to the idea of data science and the visualizations and model, even if they don't know the details, getting the insights out of the data. But the back end part of setting up the data infrastructure that makes that possible is something that a lot of people don't have a good intuitive sense of what's going on with that and how that works. So I think for a lot of people at data engineering, people don't have a good sense of what they actually do with their time. The next point here that is a good one is that as a data engineer, you're a jack of all trades and master of none, meaning that, as we mentioned, the tool stack for data engineering is a really big one. And there's a lot of skills that are required to learn. As I was just saying, as a data engineer, your role, you do a lot of interfacing with everyone else in the organization. So even though you're working with data, in some way, your role is a little bit less specialized in terms of any particular tool. And that's something that means that, again, your role is not as visible, and it's harder for people to understand what you do. Now, the next point is about being detail oriented. This is something that obviously Parham and I are really passionate about data engineering. We've both done it for years and we love it, but it's not for everybody. It can be intense. You have all this data coming in. A lot of times you're trying to build a pipeline in a demanding environment. There's a lot of different people that need to access the data in different ways. And so there's a lot of different things that you have to stay on top of. And that can be when you're on top of your tool stack and you know, when you're really that your skills are right and you're in the right setting, it can be extremely rewarding, but it can also be really intense. So we want to make sure that everybody, as passionate as we are about trying to open up data engineering opportunities for people, that we want to be clear about what the role actually involves. The next thing on this list is the idea that there's no entry-level jobs. And this relates to how complex the tool stack is, how many skills are involved. I've been in tech, Parham and I have both been in tech for a couple of decades. And as a data engineer, there's a lot of different things involved. There's programming, there's working with databases in SQL, there's all the different cloud tools, which is a whole area on its own. And it can be hard to get into that. Part of the reason why there's a lot of jobs posted and companies are having trouble finding data engineers is that it can be hard to get to the point where you have enough skills to be able to do the job. And so this idea that there's no entry-level jobs, part of the reason why we're passionate about technical education is to try to help people in whatever learning path they're going to follow to be able to acquire the technical and other resources to be able to do this sort of job, because it is demanding.
If I jump in, yeah, I kind of think actually, I mean, the no entry-level jobs, it's mostly a perception. So a lot of data engineering jobs are not listed as entry level. I want to say that's not for entry level or less, you know, experienced somebody that doesn't have 10 years of data engineering on their resume, or, you know, 5 years of data engineering on their resume. They can still apply for this because people see this as a skill that touches a lot of different things, like the managers at company. They tend to not list those jobs at entry level. But again, if you see it, the supply and demand, even there's so many jobs out there that even if you have some of these skills, which we're going to show you just in a second, just very basic skills, 5 skills, and we've got it down to 5 skills that we think if you learn these 5, you can apply for all of these jobs. We highly say to apply for those jobs.
Yeah, one of the biggest takeaways from this is, as we've been saying, just the supply and demand curves of data engineering, because in some ways it is something that there's a lot that's involved with getting into it. But the biggest thing is that there's just so incredibly much demand out there for data engineers right now. That's really kind of the overriding thing in the industry and in tech. It's just there's so much demand for data engineers. Every company is hiring for them, and there's so much more demand than there is supply.
Yep.
Yeah.
All right, and here's our 5 tools. I'll let.
So the tools to learn, and these are things that that we talk about in much more detail in our course. But this is what we think is from our many years experience in discussing this. This is kind of our basic tool stack in order of what we think are the basic things that to be a data engineer that you should have some familiarity with. So the first thing that's listed here, and these kind of all group together. Bash refers to Linux style or Unix style command line interfacing to be able to run commands in a terminal. That's a skill that, you know, even though a lot of the cloud tools have web-based interfaces, having some familiarity and some proficiency at the command line is extremely helpful as a data engineer. So that's on this list for a really good reason. The next thing is Python. Now there's a number of different languages that come up in data engineering, but Python is far and away the language of data engineering. Not only was it really designed for that, but it's just because it's easy to learn, it's intuitive, it's expressive, it makes it easy to do things that in Java or some of the other languages even that are used for data engineering, that just it makes it easier to be productive and to get really complex things done. And that's why Python has just become the top language by far to learn for data engineering. And the last one on this list is SQL, which is shorthand for structured query language, which is the language or family of languages that are associated with relational databases. SQL is a language that lets you, when you have database data and tables that lets you access that data, select things, combine data from different tables, make updates, deletions. So SQL has been around for some decades now, and it's sort of the core language of working with databases. The next thing on the list is Docker and Kubernetes. So Docker is a containerization technology that's has really taken over the way software is developed in the last few years. It makes it easy to package your application along with the word is container, in a container that has all of the things that application needs to run. So it makes it really easy to standardize deployment of applications across platforms. Kubernetes is sort of the next level of containerization technology, because Kubernetes is a technology, an open source technology that Google has very heavy investment with, that is for container orchestration. So it's a way that you can, at a large scale, manage that process of actually deploying these containers. Google, I saw one of their talks and they were talking about, I think it was just for the Google web search, that they were doing like 100 billion container pulls a week to be able to actively deploy search or one of their big applications. So at that scale, you have to have some kind of serious technology to orchestrate and manage all of that. And that's where Kubernetes comes in. Spark is a highly parallel data processing language. It's something that is another open source project that exists in some ways independently on the cloud, but now all the major cloud vendors have their own version of that. Spark is a really important language to know. It's a really important part of the data ecosystem. It's something that, it can be a little bit difficult to learn, but it's a very important skill, because particularly when you get into big data, it lets you much more efficiently do the kind of big data. It's optimized for big data sort of transactions. And the last thing on the list is Airflow, which is sort of an orchestration or scheduling tool that's used heavily for data engineering, but can be used really to orchestrate any task. And anything you want to say about Kafka?
And Kafka, yeah. So Kafka is a real-time data processing, data ingestion engine. It's highly used for real-time data processing. It's sort of the backbone of a lot of data engineering flows. But I think the big point I want to make here is learn these on the clouds, right? So the Docker Kubernetes, again, like Guy said, is a containerization platform. That's actually very good cloud agnostic tool to learn. So that knowledge is a knowledge that you can transfer to all the cloud, Amazon, Azure. And it's so popular that cloud vendors haven't even changed the name of that service. So it's called Google Kubernetes Engine, Azure Kubernetes Engine, Amazon Kubernetes Engine. It's the same. Spark is called different on every cloud. The cloud vendors take these open source technologies, they change them a little bit, and then they provide them as a service. So Spark on Google is called Google Dataproc. On Azure is called Azure Databricks. Databricks is actually the company behind Spark. AWS on AWS is called AWS EMR. Kafka on Google is called Google PubSub. On Azure, it's called Event Hub. On Amazon, it's called AWS, is called Kinesis. Airflow is Google Cloud Composer on their service. And Amazon and Azure, actually through a very promising company called Astronomer, provides managed services of Airflow on those platforms. And Airflow is becoming one of the top tools in data engineering. But I want to stop here. Do you want to show them Replit and data? Yeah. We want to show you a couple of sites that might not be your traditional Google search when you come to learning data engineering or Python, some of these skills that we think are actually very good, especially in the realm of learning with others.
Yeah, so there's, Parham talked a little bit earlier about more than one learning path to getting your skills, to getting the skills for being a data engineer for any skill set. And that's definitely true. One thing we want to highlight is how many amazing resources there are out there for learning. And if you're doing self-learning, whatever your path is, Kaggle is a good example of this. So Kaggle is kind of a data science and data engineering hub that has a lot of great data sets and other resources. But one of the things that's just really fantastic about Kaggle is that they have these interactive programming tutorials and exercises. So the way these are set up is that there's a lesson that has some content, and then They even have part of their infrastructure is that they have these great notebooks that have interactive code blocks. So you can actually program, do a lesson, program, write code, run it, see the output of it, along with instructions. And it's just something that makes it so easy and fun and engaging to learn Python or any other language. And another really cool resource, Replit is one of them. There's a number of them out there, but this is what's an interactive, what's called an IDE, or an integrated development environment. So this is something that you can just run in your web browser without downloading any code. And it's a really functional IDE. I have just a little bit of Python code up here, but it's like they support all the major languages: Python, JavaScript, Java, Go. And this is another great resource that, again, you don't even have to install any software. You just open a web browser and get working, and they're packaged in with different tutorials and different exercises. So it's just, again, it's so much fun. It's so much more fun and easy to learn a lot of these really technical things than it was when 20 years ago or 10 years ago, when I was doing this.
And this is great because you can do it with a friend, right? So you can open Replit with a friend, so you can actually co-program at the same time, and you can see the same code in the screen.
Yeah. Totally. What should be us code?
I think we can jump to ours and then show. Yeah, back to slides.
Yeah.
So what we want to jump to. So we also want to show you guys, I mean, our stack. So we also have a data engineering bootcamp. It's called Data Stack Academy. We think this is the most comprehensive program that we've put together, and I'll take you guys through that in a second. But if you go to datastack.academy, that is a URL, or if you want, you can go datastackacademy.com. You can get a lot of information about our bootcamp. You can actually start for free. So this bootcamp is going to have 10 chapters. Each chapter goes through one of the major tools of data engineering. But the very first two, the fundamentals, Python and SQL, you can get started on that for free. So there's a button there, you can click on it, and we'll send you those first two chapters for free, which Guy will show you guys here in a minute. There's tons of other good resources out there. You can, if you need to know more about this, you can schedule a call that actually goes to my calendar directly. I would love to talk to you. So if that's a program that you're interested in, schedule a call with me. We can spend 30 minutes, an hour, whatever time it takes. I can answer any questions that you have, show you the different paths. If you have different paths, we can discuss it, all of that good stuff. And there's also a link to apply. We're going to have a class starting in January 3rd. Our instructor is actually Guy. So Guy will be instructing that class. It is a 17 or 20 week long project. The very interesting thing about this, that it follows with an internship, and I'll talk to you guys about that in a second too. But we will place you in an internship as part of our program, and we'll talk about that. This is a great way to start building your GitHub portfolio. Those first two chapters that we mentioned, I believe there's like 30-40 exercises there. There's 3 or 4 full-fledged projects that you would do. Again, it's on GitHub, so you already be on GitHub, and you can get started actually building your portfolio there. Like I said, I mean, I've been in this industry for like 20 years, and I can say this really with absolute certainty and sincerity, that this is the most comprehensive program that we've put together. I'm not going to lie to you again, it's a little intense. There's a lot of things that you would learn here, but if you learn this, I will 100% guarantee that you will have a job in data engineering. What's really different about this is that we have put a cloud first mentality in our curriculum. So as we teach you these big open source technologies, we would immediately jump into the cloud and showing you how to use those technologies on the cloud, because cloud is the next thing. I mean, everything's being done on the cloud now. We chose Google Cloud for our course. No reason to choose Azure or AWS. We think Azure is really good. This is probably a whole other webinar, but I would recommend either Azure or Google over AWS for some reasons right now. But the reason that we chose Google is because, again, we said all of these cloud vendors take the open source technology, they change it a little bit, and then provide as a service. Google is the closest to the open source version. So when you learn this, you really learn the basics, the fundamentals, and that's easier to transfer to other clouds like Azure and AWS. And that's the reason we chose Google for this. Plus, they give you a free $300 cloud credit, which is more than enough to learn the skills in our course. The thing that's different about this course or bootcamp that we like to just highlight quickly, we really, I mean, when we made this, all our thinking every day is how for you to get a job. And if we've done everything to prepare you to do that. The class is completely instructor led. Guys, they're 8 to 5 a.m. 8 to 5 every day. There's instructions during the day, and then afternoon is all programming and exercises around those instructions. Guy's going to be there the whole time. I'll be there as the mentor. You can schedule a time to talk to me anytime. At least I would say once a week. We can talk and make sure you have everything you need. And the career services that we provide along with this. So as I mentioned, we will place you in a mandatory 5-week long internship at the end of this with one of the big data companies. And that gets you a foot in the door, right? That gets you working there, that gets you working as a data engineer, gets you familiar with the process, and it's something that you can add to your resume. That is something that we place you under. And then on top of that, we have career services. That's really where our job, I think, begins, where we help you actually find your first job as a data engineer. I like to close this by saying that we know that this is a big move for a lot of people. I remember, back when I made my career switch into data engineering, but data engineering wasn't even that well known back then, but I used to be a hardware engineer, a computer engineer when I designed chips, and I immediately realized that that's not what I wanted to do, and made that change. I say this, that we know what this process is like. It's a big decision. It's scary. Guy's been there in his career. A lot of people that you guys don't see that are behind the scene that actually build this course, they are people who actually have gone through boot camps. 3 of our colleagues graduated from boot camps. So they had a complete different major, complete different career, and they made that switch. We know it's scary. It's a big scary move.
and that's a big part of why we're just passionate. We want to help in any way possible by providing information, by the career services, just by all these hands-on resources, because we want everybody to feel well supported, and whatever your learning path is, we want people to be excited and engaged, and to get to that place, that rewarding place that we all want to be at. So
and that rewarding place, we can guarantee it is a job. There's a lot of jobs out there on data engineering, and again, if you go through this process, learn these tools, go through this program, we can guarantee you that you will have a job. And this is by far the biggest job in tech right now, that is very high paying, and it's here to stay because data is not going anywhere. Unless
companies aren't going to have any less data anytime soon.
Yeah, I mean, unless we have a big catastrophe that, but I think then humans altogether are in danger then. But aside from that, I think data is here to stay, right? So that concludes our little spiel here. We can open this to Q&A. Guy can also show you guys those first 2 chapters that we talked about if you guys like that. We can, but we highly recommend that you go on Data Stack Academy. You can get all the information there. You can register, and for free, we'll send you those free 2 chapters. Again, don't be a stranger. Please talk to us. I would really highly welcome if you guys want to go off mute, ask us questions, please engage us. We're here to help.
I think Ilya had a question already in the chat.
Oh yeah,
about pet project. He was asking like, what's a good pet project for
yeah, maybe if you don't mind, I will ask it with a voice.
Yeah, we can hear you.
So I just want to extend my question a little bit. So that's what I heard a lot for the people switching in general to IT, and especially for the software development. Yeah, so like build your own portfolio, do some pet projects, put it on the GitHub, and this is you can show your skills with that. The same actually for the data scientists. Yeah, they can do the Kaggle competitions, also put things on the GitHub. I'm just wondering what is the good way, let's say, not exactly like the precise example, but what is the good way for the data engineer to show? Because we need a lot of like big tons of data, let's say. Yeah. We need the Spark cluster running somewhere. And eventually, even if it's in a cloud, we get the free credits in the beginning, but eventually we have to pay for that. So
I would say, again, and I'm going to reel it back in that GitHub sort of thing. So yes, you have to do these things. And I'm not going to tell you which project, right? There's tons of projects out there you can get your hands on. Again, Kaggle has a bunch. Our course is based on open flight data sets. So actually commercial flights that have taken, real flights that have taken, and that data is public from FFA. You can download our data and use that. I would also say a lot of companies have free data APIs, right? Use those, even your own data. Like go to Netflix. Netflix has API. You can use your own data at Spotify. You can use your own data, like what you listen to. What you demonstrate on GitHub is not necessarily the actual, I mean, of course you have the code that did the process that that project required. Really build that README of your GitHub. Build that like showcase, the README, your project README that shows on your GitHub, and show the architecture. Show what you put together. Put a little diagram. These were the different pieces. So that shows like, the different pieces that goes into building a pipeline. To me, if I'm just glancing over your project right there on the README, and put a little visualization. I also say this, I know data engineering, again, it's not as sexy, right? There's not too much to show because it's just a process. You build the process. There's not that like big visualization, but you can use Google has Google Data Studio, which is a really great lightweight data visualization tool. So your results, you can add a couple charts, go do a couple clicks. It's very easy to learn. And you can add a couple of charts and actually put those on your README too. So if you wanted to add that visual aspect, that kind of gives you that as well. I think as an employer, again, if I see those things, if I see like a little architecture diagram where you explain the different pieces, then I know what you're talking about, right? And when I see a little visualization, that's just for everybody. Everybody likes a little eye candy, right? So that helps.
Just a couple things that I would add to that, Ilya. I really appreciate that question. And as somebody with a fair bit of data science background that's kind of pivoted back to data engineering, you make the good point that in some ways it is easier with data science. You can go to Kaggle, there's a million data sets, there's projects that you can kind of already be led through and make in a notebook, and it's easier to sort of have some sort of presentable, deliverable thing. And with data engineering, it's not quite as straightforward, because when you're building data pipelines, a lot of times there's just more to it. It's not something that's as visible, but a key word that Parham mentioned is architecture. And this is something we focus on a lot in our course that's really important. If you're doing anything on the cloud, but especially as a data engineer that's building complex data pipelines that need to scale and be high performance. And that is, I would say, one of the biggest resources. All the major cloud vendors, Google in particular for us, have a lot of great reference material on their reference architectures, and particularly for data engineering and what best practice data pipelines should look like. And those are very well integrated with their documentation, their tutorials. So I'd say one of the easiest, best free things you could do is just go to Google Cloud website, search for data engineering pipelines. They have so much reference material with visual diagrams and that are linked to tutorials. Those things are a really good basis for a project like this, because as Parham said, it's not just the individual pieces, but it's something that where you can demonstrate, and if you do even a small project like this, you can demonstrate an understanding of the bigger picture of cloud architecture and how pieces fit together to build scalable data pipelines. And that's what employers are really looking for, and what's hard to find. Yeah. A lot of people know the pieces, but not the big picture.
And just the fact that you showed the cloud, I think that's major points for anyone, totally. Right? Like, I hope that answered your question. Do you have a follow-up there, or was that?
No, thank you. Yeah, thank you.
let me actually stop our share so you can see us a little better. All right. Let's see if there are any other questions. Anybody else? If you guys have any questions, we're here. Also, again, don't be shy. Don't be shy to go off mute. Just introduce yourselves. Say what your background is. We love to even see where you're coming from. What's your background? Why? What's your thinking behind? You know, if you want to make this change, what you're thinking. What is? Yeah, what's holding you back? Anything.
I can share the first couple chapters of the curriculum.
Yeah, that would be great. If you guys don't mind, Guy can actually show you guys the first 2 chapters that we have on Python and SQL really quick. You want to share again?
Yeah, oh yeah. So I'm just going to open up Microsoft VS Code here. This is the IDE that we recommend for our course that we've had a really good experience with. And this is just showing some of the material from the first couple chapters of our 10-chapter curriculum. The first chapter covers Python pretty much from scratch, walks you through learning Python. This is what's called a Jupyter Notebook, which is this great tool that lets you package code and comments in line. We use these heavily for our course because they're such a good way to present and also run code interactively. So the course starts with basic Python, goes through, there's built-in exercises. We also focus on, we teach, as we showed in the presentation, Bash, command line, and Git. We want you to have the skills of Git and GitHub. So there's, this is chapter, just walking through the episodes here, the first chapter, this is more Python material. We go into the different collection data types, control flow, logic, loops and conditionals, this sort of thing, with examples and code built in. Python walks, or the first chapter walks through Python. We get, like in chapter 6, into pandas, which is the very common data engine or the data manipulation package that's heavily used by data scientists and engineers. So the second part of chapter 1 is pandas and that material. Chapter 2 goes into databases and SQL. So we have a lot of material here, this foundational material on databases and SQL. We have you know, all of our material is designed this way with instructions with code examples built in. So we try to, even though it's a lot of information, make it as clear as it can possibly be. So if you go to datastack.academy or www.datastack.com, datastackacademy.com, you can, if you just click the get started for free button and you put in your email, and it'll send you a link to this public GitHub repo that has the first 2 chapters of this material. You can look through in your own time and see how the curriculum is designed. There's a course overview there. You can walk through some of this material on your own. It'll give you a good idea what to expect, and just if you're interested in data engineering in general, what that looks like. So that's definitely, we want to provide that to people so you can help get yourself oriented in the realm of data engineering. So definitely go sign up and get access to the first free chat, the first couple chapters. It'll give you a better idea of what we're actually doing here day to day.
All right. I guess with that, if there's no other questions, we can, let's see. I think that's what we can probably cut this short. Last chance for questions. Thanks again, everyone.
Thanks again. We appreciate your time and being here and letting us present this to you. We're really excited about it. So
yeah, appreciate it. Thank you so much for joining. And again, don't be a stranger. CJ's email's there. If you need to talk to me, it's right on the website that goes to my calendar. And Guy's always available as well. Get through us and I can put you in touch with Guy as well. Thank you so much, guys. I hope you enjoy your day.
Take care, everybody. Thank
Take
you.
care. Stop recording.